The Earth will, before long, have another moon. The gravitational pull of our blue home planet is going to capture an unfamiliar heavenly body and briefly make it its buddy, as opposed to our notable moon. However, this natural satellite is somewhat smaller. The space rock, 2024 PT5, is only 10 meters in size. After just 2 months, it will break free from Earth's gravitational field and vanish into the vastness of space. It's a moonwalk of a different kind in a way. Discovered on August 7th of this year by a South African-based telescope of the Asteroid Terrestrial Impact Last Alert System Atlas, Space Rock 2024 PT5 will leave its horseshoe-shaped orbit on September 29th and get very close to Earth's gravity. More precisely, the vast protuberance will experience a so-called temporarily captured flyby and, for about 2 months, more exactly, for 56.6 days, become a mini-moon of the Earth. In detail, however, this interesting event does not mark a cosmic novelty. In truth, smaller space rocks repeatedly get trapped in the invisible hold of our home planet, only to become new companions. However, we have only been aware of this phenomenon for about 12 years. After astronomers from the Catalina Sky Survey in Arizona detected an object about the size of a small car in Earth's orbit in September 2006, they initially didn't know whether they were dealing with a natural chunk of rock or just a piece of space debris. The only thing that was certain was that the object left Earth's orbit in June 2007 and headed towards the Sun. In the aftermath, space experts debated whether the event was an outright exception or whether our Earth might consistently capture small asteroids and briefly make them its sidekick. Finally, this debate was not settled until spring 2012, after researchers at the University of Helsinki used a supercomputer to analyze the trajectories of 10 million near-Earth asteroids. Apparently, there is almost always a small satellite with a diameter of at least 1 meter in Earth's orbit, and while these mini-moons orbit the Earth an average of 2.9 times before they leave again after about 9 months, there are also mini-moons that stay in Earth's orbit for a much longer time. But doesn't this rendezvous with captured asteroids also pose a certain risk? Could the celestial body not lead to impacts? Well, according to experts, this scenario poses a danger to us only in the rarest of cases. After all, only 0.1% of the rocks that have collided with Earth's surface so far are thought to have had a past as mini-moons. How 2024 PT5 will become a new moon of the Earth. The forthcoming mini-moon visit is categorized as an Arjuna asteroid. This class of near-Earth asteroids is characterized by their Earth-like orbit, with low inclination, low eccentricity, and an orbital period of around 1 year. Since these corresponding celestial bodies orbit the Sun at the height of Earth orbit, they often become Trojans. And while this term generally makes us think of wooden horses and mythical battles, in astronomy, it refers to asteroids that precede or follow a planet in its orbit. Our natural home, in turn, has 2 known Trojans. However, most of our companions move in a horseshoe orbit, which occasionally brings them within a few million kilometers of us. By galactic standards, this is a very small distance, and it's also expected in the case of 2024 PT5. Between September 29th and November 25th, it will pass just outside the Hill sphere and therefore around 1.5 million kilometers from Earth, and will fall into the gravitational grasp of our home world. A short explanation. In cosmology, the Hill sphere describes the environment of a body in which its gravitational force is more effective than that of another, more massive body that it orbits. However, anyone hoping to marvel at 2 moons in the night sky in the near future will, unfortunately, be left disappointed. Although PT5, at 10 meters across, is one of the larger mini-moons, it is still too small and too far away to be seen by the naked eye from Earth. In fact, it is likely to remain invisible even to smaller telescopes. But at least it will pay us another visit in the future. When the asteroid returns to a heliocentric orbit at the end of November, it will initially remain in our vicinity. On January 9, 2025, it will approach Earth once again, to within 0.012 astronomical units, or 1.7 million kilometers. In the period that follows, however, the lunar on-off relationship will then be put on hold for the time being. The cosmic bump will completely leave the area of the Earth and will not enter our domain again until 2055. This strange mini-moon presents experts with a significant mystery. Despite its short stays, 2024 PT5 may still help us solve a completely different space mystery. However, this space mystery does not concern our Earth, but rather our planetary neighbor, Mars, the red planet, joined by two moons, Phobos and Deimos, whose appearance can with certainty be depicted as uncommon, considering their odd appearance. Numerous scientists think it is possible that Phobos and Deimos once flew through space as asteroids before being captured by the gravity of Mars and brought into a steady orbit. But this isn't the only possible explanation for these extraordinary Martian companions. With respect to Phobos, it is also possible that we are dealing with a concentrated field of debris. A space rock could have once crashed onto the surface of Mars, causing part of the crustal material to be flung into space, where it gathered to form a new celestial body. Another hypothesis suggests that Phobos and Deimos are, in fact, the remnants of a larger and older Martian moon that broke apart approximately 2.7 billion years ago. In the face of this fascinating mystery, we shouldn't forget that our own moon still holds numerous unanswered questions for us. To this day, we can't say with full confidence how it was formed. One hypothesis points to a collision. According to this, a Mars-sized celestial body may have crashed into the young Earth in the early days of the solar system, with the material flung up in the process eventually coalescing to form the moon. And while in this scenario we would have given the moon a portion of its material supply, it is also possible that the reverse is true. According to an exciting speculation, our steady companion has given back and provided us with a small moon in return. In detail, this refers to the asteroid Kemwalwa, which at 50 meters is about 5 times larger than 2024 PT5, and also orbits our home planet as a mini-moon. While these co-orbital companions are also known as semi-satellites in expert circles, astronomers have long been pondering the origin of Kemwalwa. Most mini-moons were ejected from the asteroid belt by collisions or gravitational turbulence and then captured by Earth's gravity. However, curiously, Kemwalwa's trajectory defies the usual mini-moon pattern. The celestial body apparently alternates between a circular orbit around Earth and a horseshoe orbit. And while, as mentioned, mini-moons are not known for staying in Earth's vicinity for long periods of time, this object has lingered in our neighborhood for an unusually long period. Strictly speaking, Kemwalwa has held its current status as a semi-satellite for almost 100 years, and according to experts, it will be at least another 300 years before it returns to the horseshoe orbit. Moreover, the changing of orbits could continue for many thousands or even millions of years. But what is the reason for this peculiar behavior? Perhaps the answer lies in the composition of the celestial body, which differs significantly from that of typical near-Earth asteroids and is more reminiscent of the regolith that thrives on the surface of the moon. Considering this, suspicions arose as early as 2021 that Kemwalwa could in fact be a lunar rock that was once knocked out of our satellite by an impact. How the moon gave Earth a small moon, while sounding plausible at first, unfortunately has a fundamental catch. For a long time, such a scenario was considered very unlikely or even impossible by experts. This is because if a piece of the moon had enough kinetic energy to escape the moon's gravity, it would actually have too much energy to swing into an Earth orbit as a mini-moon. To test this hypothesis again, a research team from the University of Arizona virtually simulated fragments being ejected into space by impacts on the lunar surface from all possible regions, angles, and speeds. The result was that most of the ejected fragments do not, in fact, make it into low Earth orbit. But, as is so often the case, exceptions prove the rule. After all, 6.6% of all impact fragments have managed to enter a co-orbital motion temporarily, with a portion of 5.8%. Most of them were subsequently found in horseshoe orbits, but 0.8% showed a shift between horseshoe and semi-satellite orbits. Moreover, there are also several factors that favor the entry of a moon fragment into an Earth orbit, specifically those fragments whose speed when ejected is only slightly above the necessary escape velocity of 2.4 kilometers per second. These are the most promising mini-moon candidates. And although most of the simulated objects only spent a short time in Earth's proximity, there were also some that had stable orbital dynamics similar to Kamiwawa. There is no doubt that such a case is extremely rare, but the research results show that it is fundamentally possible. In other words, the origin of the mini-beast Kamiwawa could indeed be right next door. And the origin of your subscription is right under our video. Feel free to click like and subscribe so you never miss another fascinating video from us. We'll see you soon.